My topic is type of mechanical property of the metal. Different type of the mechanical properties are given here. Number one is strength. The strength, it is the property of the material by virtue of which it is able to withstand or support the external load without any fracture the material. The strength of the material play a very important role to selecting the material for designing the different type of the machine parts, components and agriculture's parts. Number two is elasticity. This type of the material able to restrain original shape and size after removing the external load. The rubber is the best example of the elasticity. So you can see this figure. This is the base plate, this is a rubber block, this is a pressure plate. When the load is applied here, the rubber is squeezed. So after removing the force, this type of the material it is able to retain its original shape and size due to the elasticity. So you can say that the rubber is the best example of the elasticity. Number two is plasticity. It is not able to retain its original shape and size after removing the force, after removing the external load. The plastic is the best example of the plasticity. So this is a base plate, this is pressure plate, this is a plastic material. When the force is applied on the surface of the plastic object, after removing the force, it means that there is no any change in shape and size. It means that the plastic is the best example of the plasticity. Number four is ductility. It is the property of the material by virtue of which it is able to the metal is drawn into the wire without any fracture. The ductility of the material are generally depends upon the grain size of the material or crystal. The ductility is measured in the percentage elongation and percentage reduction of the cross-section area of the workpiece. The ductility, the elongation 5 to 15%. So that this material is considered in the good ductility material. The percentage elongation is 10%. So you can say that this material is considered in a medium type ductility material. The less than 5% elongation, this material is considered in a hard or brittle material. So ductility generally depends upon the size of the grain size of the material. The band steel, copper, aluminum is the best example. Lead, tin is the best example of the ductility. Number five is malleability. So it is the property of the material. It is roll the sheet in the material is roll and hammering in the sheet form. The malleability is also depends upon the size or grain size of the material. If the grain size of the material is very small, so you can say this material is very thin sheet. The grain size is more, so you can say that this type of the material will a thick sheet. The malleability, the wrought iron, aluminum, copper are the best examples of a malleability. This is a brittleness. So it is the property of the material by virtue of it is fill the material with the appreciable deformation. The brittleness is the just opposite to the ductility. The less than 5% elongation, so it means that this material is considered in a brittleness. The concrete, cast iron and glass is the best example of the brittleness. Toughness, so it is the property of the material by virtue of its the maximum energy is absorbed by the material without any deformation take place. Hardness, so hardness, it is the property of the material. It is resist to scratching, indentation and cutting the other material. The hardness of the material can be measured by the four types. Number one is brittle hardness. Number, you can calculate this, use this formula. P is equal to pi d by 2 d minus dk square root. The P is the applied force. So this is the diameter of the ball. D is the diameter of the intention ball. Small d is the diameter of the impression diameter. The impression diameter, this is the workpiece. This is the ball diameter. The D is the capital D is the diameter of the ball. This diameter, D is the impression diameter. D is the impression diameter. You can use this formula. Diameter of the ball, you will be take the 2.5, 5 and 10 mm. 10 mm. The thickness of the workpiece, you will be take the T is equal to 8 times of impression diameter. Impression means this is the depth of impression. The depth of impression 8. The 8 means this is the 5. So it is 5. So it means that 40 mm thickness of this material should be used for the testing the Brinell hardness number. Brinell hardness number. So Rockwell hardness, second number is Rockwell hardness. Number 3 is Weaker hardness, and number 4 is micro hardness. Micro hardness. This micro hardness. This is the 9 is resilience. The resilience, it is the property of the material by virtue of it is absorb the shock absorber impact load without any fracture the material. So the spring is the best example of the resilience. Number 10 is creep. Creep. So it is the property of the material. It is the property of the material by virtue it is able to deformation. Slow. It is able to deformation is very slow at a constant. At a constant stress. At a constant stress, the material, this type creeping are occur in this material when the material is subjected at a high temperature for a long period. Remain that the progressive crack in this progressive crack after the permanent. This creeping test is very important to checking the material for designing the shaft, crankshaft and bearing. Different type of the material are designed with the help of a creeping test. Creeping test. Second, the creeping test are generally are used a combustion engine, boiler, turbine, missile. They are working at a high temperature for a long period. So the creep test is very important to designing this type of the items. Number 11 is fatigue. So it is the process. It is also property of the material. It is property of material. The metal is fail. The metal is fail up to the elastic below the yield point. Below the yield point at a repeating stress. At a repeating stress. Repeating stress means the crankshaft, spring, gearing. These items are designed with the help of a fatigue test. Fatigue test. The fatigue test just like a this is a log 10-3, 10-5, 10-4, 10-5, 10-6, 10-7 up to this. This is the stress. This is the number of cycle. Number of cycle. If you want to check the fatigue test for the aluminum material, this curve is like this. This is for the aluminum. Aluminum means the stress is very low. The load is very low for the checking the aluminum. So if you want to check the alloy steel, so load is very high. The load should be very high to check the alloy steel, and this block is also called the SN ratio, SN curve. SN curve. This is the SN curve for checking the fatigue. For checking the fatigue. So fatigue is this is the motor. This is a shaft. This is specimen. Bearing. Load is applied here. The workpiece is moving at a number of cycle. Then apply the load here. Then after some time, the workpiece will be the brake here. Will be the brake here. So you can draw this diagram. The load is applied here SN and number of cycle is this is the SN curve. This is the SN curve. This is the method of checking the fatigue test. There is a machinability. So machinability, it is the property of the material. When the material is cut very easily, material कर दी easily with the different type of the machine tool like a machine single point cutting tool or multi point cutting tool. By using the single point cutting tool, by multiple cutting to easily the metal the remove. The drilling, reaming, milling, broaching, planing, these are the example of the machinability. This type of the tool are used for the machinability. 13 number is weldability. It is also a property of the material. When two material are joined without any failure, so this type of the it is the weldability is represent the quality of the material. The weldability are generally depends upon a different type of the points. Number one is hardness of the material, composition of the material, technique of the material, or filler metal of the material. These points are the different type of the points are affecting the weldability. This is the specimen for tensile test. It is made of a mild steel. This is the diameter, this is radius of this, and this is the gauge length. So what is the meaning of the gauge length? The gauge length is a working space, working length. The gauge is the working length. So all the work, all this line, the strain curve are lie. So this is the only gauge length. On the gauge length are used to draw the strain diagram. The diameter of the specimen and radius of the specimen you will be take the as per the standard. So while will we take the mild steel, the specification of this mild steel, so you will take the mild steel, so that the more detail can be obtained by this use of the mild steel. The material of the specimen in mild steel. This is a workpiece. The workpiece, the top portion, this is bottom portion. Top portion is fixed with a movable jaw, or lower portion is fixed with a fixed jaw. When the material is underloaded, so in which the stress is proportional to the strain. The stress upon strain is equal to constant. The proportionality of constant is called the modulus of metal. So it is also called the rigidity. So rigidity, it means that the stiffness. The stiffness, it is property of the material. By virtue of it is resist to deformation or deflection at a stress. So it is also called the rigidity. The Young modulus of elasticity is also, and Young bulk modulus. The bulk modulus used for the volumetric distortion. So for the tensile and compression used for the modulus of elasticity. In the first stage, when the material is loaded, the stress strain directly proportional to. This is the Hooke's law. So from the A, so you can see this figure. So when O to A. So O to A, it means that this line is draw a straight line. It means that the O to A is apply the Hooke's law. So Hooke's law strain proportional to the strain up to the elastic limit. After that, so the straight line is going on a slightly curve, slightly radius. So A to B, to B to A. So it means that this portion is called the elastic range. So elastic, it is the property of the material by virtue of it is able to retain its original shape and size after removing the external load. After removing the external load, this material it try to retain its position, shape and size. So this range is called the elastic range. So the load is applied here, the curve the curve is going to the B and C. So B and C is the range, this range are going in the category in the plastic deformation. So plastic deformation means that it is not able to retain in original shape and size after removing the force. The plastic is the best example of the plasticity. So from C to A is not try to retain in original position. This range is called the elastic range. The B to elastic range. So at this point C, so suddenly the force is down. And strain is increased. So it means that this at the C point, this is the yield point. This is the upper yield point. This is the lower yield point. C and D. So how to calculate the stress stress strength. So you will take the point is here, you will point the here, the line is draw per agar pehla to the O and A, cut this point is at point C, at point L. So L on point L. So TL is so you can read this value here. So this is the yield strength of this material. The material is not released all the strength. So when the material is broken, so some stresses is store the material not release the at a time. So when the load is applied here, the material is going up to this point. The material is going up to this point. This is the maximum. This is the ultimate tensile strength. So ultimate tensile strength. So you will ultimate tensile strength is equal to the applied load divided by the cross section area of the specimen. This is the ultimate tensile strength. The ultimate tensile, you can read this here. So you can directly read here that this is the ultimate strength. So at this point, ultimate tensile strength at ultimate tensile strength, the stress and strain is maximum. Stress strain is maximum. This is the stress is down. The stress is not, load is not allowed. The strain is increased. So after some time, the workpiece is break here at the fourth point. The workpiece is break here at the fourth point in a cupping form. So this is the breaking point. This is a knocking zone. This is a knocking zone. This is the knocking. These are the stress strain diagram. This type of the material, this type of the strain diagram, this type of the specimen are generally tested by the universal testing machine and draw the diagram, the strain diagram, and calculate the different type of the mechanical property with the help of the strain diagram. So the mechanical property play a very important role to designing, to selecting the material for designing the different type of the machine parts, engine parts. Those are running at a high temperature, those are running at a high temperature and high speed. These are the mechanical properties. So I hope that you will like my lecture. Thank you very much.